Hello everyone and welcome. We are Team Control All Delete and we are excited to present our solution for Smart India Hackathon 2025. PRISM. PRISM stands for Prediction and Risk Identification for Student Mentorship. It's our answer to the critical problem of creating an AI-based dropout prediction and counseling system. Student dropout is a major challenge for educational institutions, and our project under the theme of smart automation offers a powerful proactive solution. So, how does Prism actually work? This slide shows the core engine of our solution. Our goal is to shift student support from being reactive to being truly proactive. The process is broken down into two parts, the one time training phase on the left and the ongoing prediction phase on the right. First, in the training phase, we take a student data set and split it into 80% training set and then 20% testing set. We use the large portion to train a light GBM classifier, a fast and highly accurate machine learning model. We then validate it on the test data, achieving a strong overall accuracy of 88.1% and a ROC area under curve score of 0.83. Now for the live system, on a weekly basis, an admin simply uploads CSV files for attendance, assessment, and fees. Our system automatically merges this data and applies a pre-trained model to predict the dropout probability for every student. Based on this probability, we use simply threshold logic to categorize students. A probability of zero point 0.7 or higher is classified as high risk. A probability between zero point 0.3 and zero point 0.7 is moderate risk. Anything else is considered as low risk. This clear color coded system allows mentors to immediately see who needs their attention. Let's dive into technical architecture that powers Prism. The system starts with a central login that provides a unique role-based dashboard for four key users: the admin, the principal, the HOD, and the mentor. The admin uploads the weekly data files, which triggers the ML prediction and automatically sends high-risk alerts to mentors and guardians. The principal gets a high-level institutional view with risk distribution charts and department overviews. The HOD sees a similar data but filters specifically for the department. Finally, the mentor gets a focused view of only their assigned mentees and can log intervention notes, creating a vital feedback loop. We built this using model scalable and fully open source tech stack. For front end, we used Streamlit and Plotly for clean interactive dashboards, whereas for backend, we used Python with LightGBM for ML predictions. For database, we used MongoDB to efficiently store all the student mentor predictions. Feasibility, challenges, and viability. Our idea is only useful if it's feasible in real world. We have analyzed Prism from every angle to ensure it's not just innovative but also practical and sustainable. Technically, it's built on 100% open source Python and MongoDB stack, guaranteeing scalability and instant ML predictions. Operationally, it automates alerts, shifting mentor support directly from reactive to proactive action. Economically, it achieves zero licensing cost and ensures a high ROI through improved student retention. This all leads to long term viability, guaranteeing lasting value for any institution. While we are confident in our project's feasibility, we are also anticipated potential challenges and have proactive solutions ready. To ensure input data reliability, we implement CSV validation checks to confirm all required headers exist on every upload. To combat model drift and accuracy issues, we have a protocol to retrain the LGBM model every semester to keep it sharp. We know faculty resistance at adoption can be a hurdle. That's why we have focused on an intuitive user experience and will train staff on simple check risk and add note workflow. Security and privacy are non negotiable. We use strict role based authentication to restrict the scope of data each user can access. Finally, to minimize deployment and downtime, we utilize the stability of MongoDB and other robust components to ensure high uptime for system. Coming to impacts and benefits. So, what is the ultimate impact of implementing Prism? The benefits are comprehensive. It offers real time insights, transforming support from reactive to proactive planning. It allows for early detection, flagging at risk students weeks before academic failure, which is crucial for implementing intervention. This directly empowers mentors with automated targeted alerts. The most significant result is improved retention, which helps students achieve their goals and secure institutional revenue. Lastly, it enables data driven allocation of resources by helping administrations identify struggling programs. Coming to research and references, our approach is firmly grounded in established research and best practices. Our research confident that data fusion, combining diverse data points, is essential for accurate prediction. Studies guided our model selection towards that tree-based models like LightGBM, which offers the best balance of accuracy and speed for deployment. We learned the importance of closing the action gap. Predictions are meaningless if they don't trigger any immediate automated intervention. Finally, the best practices informed our role-based dashboard design and a scalable operational architecture using a NoSQL database like MongoDB. In conclusion, Prism is feasible, impactful, and data driven solution to one of the biggest challenges in higher education. It empowers institutions to intervene early, support students effectively, and improve success rates for everyone. Now, let us look into the prototype demo. Thank you for joining this walkthrough of the University Dropout Risk Analytics platform. This robust application uses Streamlit, MongoDB, and Python scikit-learn to predict students' dropout risk. The system is designed to provide role-based intelligence, ensuring every member of the academic team, from the admin to the individual mentor, gets the data they needed precisely when they need it. Let's start logging in by the system admin. The admin's core task is to upload weekly student data. We need three files: attendance file, assessments, and fees. When I click on the process and save, the backend does four things for us. One is it runs the data through the machine learning model to generate a dropout probability, analyze the risk level like high, moderate, as well as low, and saves all the predicted results to the MongoDB database. And here we have the risk distribution. The pie chart shows the percentage breakdown of the entire student body by risk level. This guides high level resource planning. Next, we have performance analysis. These two scatter plots are critical for understanding the model's behavior. We see the clear correlation. As marks or attendance fall, the dropout probability increases. These red dots, representing high risk students, cluster dangerously close to zero attendance as well as low marks. Next, we have the department overview. These box plots compare the central tendency and spread of metrics like attendance or marks across all the departments. This allows the admin to spot which departments are struggling or excelling dividing policy decisions. The main table here, every student showing their computed risk as a progress bar. Student marks as green for low risk, yellow for moderate risk, and red for high risk. The high risk students are for our immediate intervention. The admins can use this send high risk alert button. When clicked, it triggers an email notification to the mentor of these students, automating the intervention handoff. Now let us log in into any one of the mentor ID to check if they have received the email. Here we can see that the corresponding mentor has received an email telling his mentee has been flagged as a high risk and they need intervention. To demonstrate how platform tracks progress, the admin can quickly add files of corresponding weeks like week 2, 3, 4. Now let us continue the same process for week 3 and 4 simultaneously. Here I have updated the files till week 4 and all the corresponding visualizations and the main table has been updated till the week 4. The process continues as the semester goes on. Now let us log out as the system admin and start logging in as the principal of the institution. Now we have logged in as the principal. We have exact same university-wide view as admin, but without any permissions to upload files or process new data. The principal role is to oversight. They use charts, especially the department overview box plot, to compare the department's performance and identify the systematic issues across the campus. Now let us log out as a principal and start logging in as any of the HOD, for example HOD of CSC. Switching to the HOD of computer science, the data scope now narrows instantly. The dashboard title is specific. The main table shows only students belonging to the CSC department. The risk distribution is now as follows. The pie chart now only reflects the risk profile of CSC students. The department overview. The HOD can still access this tab, but since their data is already filtered, the box plot now acts as a deep dive summary of their own department's internal performance and score spread. Now let us log out as a HOD and start logging in as the mentor. The final most critical role is the mentor. After logging in, the dashboard is filtered. It only shows their assigned mentees. The mentor receives the high email alert and immediately looks for their list of high-risk students. Now by clicking any of the students, we will have the student metric page. The performance trend analytics. These line chart shows the students' attendance and marks trend all over the 4 weeks from week 1 to week 4. We can clearly see if the risk is due to a sudden recent decline or gradual sustained poor performance. Next we have the comparison bar charts between students' attendance with the department average attendance and the students' marks with the department average marks. Next we have the dropout probability GOG, which provides the immediate risk value showing how close they are to the 1.0 threshold. The next important part is we have a mentor note. This is the action area. Since the student is high risk, the mentor can use this text box to create the reason for high risk and intervention plan. This note is saved to the database. Let us suppose add any of the note like financial problem. And when we hit on the save note, and when we go back to the dashboard and look into the student of 159th roll number, we will have the financial problem noting here. So this is overall mentor overview. In conclusion, the University Dropout Risk Analytics platform successfully centralizes ML predictions and student data into secure role-based application by providing targeted time-sensitive intelligence to admins, principals, HODs, and mentors. It directly contributes to improving student retention and academic success. Thank you for viewing the demonstration.